Hey everyone, this is Lakshmi from the Department of Data Science, Semester 3rd, Subject Mathematics, Topic Way Anova. Introduction to Way Anova. Way Anova is a statistical method used to determine the effect of two independent variables on a dependent variable. It helps in analyzing the interaction between the two factors and their individual effects. This method is widely used in various fields including biology, psychology, and marketing research. Key concepts: independent variables or factors that are manipulated or categorized in the analysis. The dependent variable is the outcome measure to access the effect of the independent variables. Interaction effects occurs when the effects of one independent variable depends on the level of other variable. Assumption of two-way ANOVA. The observation must be independent of one another. The dependent variable should be normally distributed for each group. Homogeneity of variance is required, meaning the variance among groups should be approximately equal. Classifications of ANOVA test. ANOVA analysis of variance. One-way ANOVA, two-way ANOVA. One-way ANOVA compares multiple levels of one factor and checks the variance of the three or more factors. Two-way ANOVA compares multiple levels of two factors and it is used to study the effect of two independent variables on the dependent variable. Research design. The design involves categories independent variable, each with two or more levels. It allows research to explore complex experimental design effectively. Each combination of the independent variable forms a unique group of analysis. Cate- uh, mm, Definition example. Variables represent data that can be divided into multiple categories but cannot be ordered or measured. Each category can be identified by distinct label and data points are allocated to these characters based on the qualitative properties. These variables can further be broken down into uh, binary and nominal variables. Examples: hair color nominal has a pet color binary. Hair color nominal. Categories include bland, black, and red. Has a pet binary. You either have a pet or you don't, making this binary variable. Example scenario. Suppose we want to study the effect of different fertilizers and watering schedules on plant growth. The two independent variables could be fertilizer type A, B, C and watering frequency daily, weekly. The dependent variable would be growth rate to the plants measured in centimeters. Data collection. Data should be collected systematically from each group formed by the combinations. Each observation should be recorded accurately to ensure data integrity. A larger sample size is recommended to increase the reliability of the results. Hypothesis in two-way ANOVA. Null hypothesis states that there is no significant effect of the independent variable on the dependent variable. Alternative hypothesis suggests that at least one of the independent variable has a significant effect. Specific hypothesis can also be formulated for interaction effects. Null versus alternative hypothesis. Null hypothesis is statement about a population parameter. We test the likelihood of its statement begins true in order to decide whether to accept or reject our alternative hypothesis. It include equal to, lesser than or equal to, or greater than or equal to sign. Null hypothesis, a statement that directly to the null hypothesis. We determine whether or not to accept or reject this statement based on the likelihood of the null opposite hypothesis being true, not equal to, lesser than, greater than sign. ANOVA table structure. The ANOVA table summarizes the source of variation and their corresponding sums of square. It includes component for each independent variable, interaction, effects and errors. The table also calculates the mean squares and F ratios for hypothesis testing. Here are the table of ANOVA. Source of variation, sum of squares, degrees of freedom, mean squares, F value. Calculating sum of squares. Sum of squares qualify the variation attributes to each factor and the interaction. The total sum of squares is partitioned into sum of squares for each independent variable and the error. This partitioning is crucial for conducting the F test in the analysis. F ratio calculation. The F ratio is the calculated by dividing the mean square of the factor by the mean square of the error. A higher F ratio indicates greater likelihood than the factor significantly affects the dependent variable. Critical values for the F distribution are used to determine significance level. Interpreting results. Statistical significance is interpreted in the content of p-values compared to a significance level. For example, alpha equals 0.05. A significant p-value indicates that at least one group mean is different. Interaction effects requires further investigation using post-HOC test or interaction plots. Post-HOC testing. Post-HOC testing are used to identify which specific group differ from each other after finding significant result. Commonly used tests include uh, these tests help control for type 1 error when making multiple comparison. Interaction plots. Interaction plots visually represents the interaction effects between the independent variable. They help to understand how the level of one factor affect the other factor impact on the dependent variable. A non-parallel line in the plot indicates that an interaction exists. Software for two-way ANOVA. Various statistical software tools can be performed two-way ANOVA, including R, SPSS, and Python, using libraries like SLADS models. These tools provide functions to conduct the analysis, generate ANOVA tables, and perform post-HOC test. Using software enhance accuracy and efficiency in data analysis and interpretation. Limitations of two-way ANOVA. Two-way ANOVA assumes normally distributed data and equal variance, which may not always be valid. It cannot handle missing data well, as it is typically required complete data sets. Complex interaction with the more than two factors may require alternative approaches such as factorial ANOVA, one-way ANOVA, two-way ANOVA. Applications of two-way ANOVA. Two-way ANOVA is used in agricultural studies, clinical trials, and market research. It helps research make informed decisions based on the interactions of multiple factors. The method is instrumental is in experimental designs that seek to optimize outcomes through systematic testing. Conclusion. Two-way ANOVA is a powerful statistical tool for understanding the impact of multiple factors. It aids in decision making by providing insights into interaction and individual effects. Proper applications and interpretation of two-way ANOVA can significantly enhance research finding. Thank you for watching this video. Thank you everyone.